There always has been a mystery associated with pyramids, how they were built thousands of years ago, and the science behind their construction. Pyramids clearly prove that ancient Egyptians had advanced technologies in their times to build one of the oldest seven wonders of the world. There are close to 100+ pyramids scattered all around Egypt. The Great Pyramid, the largest of the three and the largest in the world, consists of 2.3 million stone blocks that weigh 2.5 to 15 tons apiece. According to archaeologists, they were quarried from a nearby source. The mystery is, how did the workers move these huge blocks? Archaeologists believe that they solved a part of one of the most puzzling questions of history, that how the Egyptians transported tons of limestone to build these pyramids. A papyrus scroll has been unearthed which shows remains of boats and a network of waterways at the site of the pyramid, providing evidences that thousands of trained workers used boats to navigate canals dug along the river Nile for transporting limestone. Ancient Egyptian mortar was used to support the joints of the huge stone as they were placed. An estimated 500,000 tons of mortar were used during the construction of the Great Pyramid. And astoundingly, this gypsum mortar is stronger than even the stones themselves and has remained in place for thousands of years. Now, coming to the science behind the construction of pyramids. There are a lot of theories that circulate concerning the alignment of the pyramids, especially the Great Pyramid, and they all agree that they cannot conclusively say how the ancient Egyptians were able to construct the Great Pyramid with such accuracy to the cardinal directions. The north and the south axis is aligned to within 0.15 degrees of true north and south. The ancient Egyptians did not even have the North Star like we do today as a guide to the true north. One of the only ways for them to have constructed the pyramids with such accuracy would have been complex algorithms, and these algorithms would have only worked close to the seasonal solstice times when the sun's alignment is more easily viewed. About 4,500 years ago, no star sat at the North Pole. Instead, all the stars in the North sky rotated around an imaginary point marking the North Pole. Experts thought that ancient Egyptians might have watched a single star circle this imaginary point and aligned their pyramids with this circle's center. Alternatively, they could have also measured the north by tracking the path of the sun. But finding the north is not that difficult. If you keep tracking any star where it rises and sets during the night and cut an angle in half, after that, squaring the sides just requires a right angle. Although Pythagoras' theorem came way later, the Egyptians knew that a triangle measuring 3, 4, and 5 on its sides made a right angle corner. A right angle could also have been made with two circles intersecting. The line connecting the intersection of the arcs is at right angles to the line through the center of the circles. But historically, still, no records have been found of the processes that Egyptians actually used to build the pyramids. But it's said that the Great Pyramid, constructed thousands of years ago, is even more accurate in alignment than our modern-built Meridian building at the Greenwich Observatory in London. The precision used to build these pyramids is incredible because in those days, even compasses did not exist. Also, another interesting fact is that the Egyptian pyramids may look like they are four-sided, but in 1940, a British pilot noticed that each of the four sides of the Great Pyramid were actually split into two by a concave indentation, creating 8 equal sides and not 4. And this is visible only at dawn and sunset on the spring and autumn equinoxes when the sun casts its shadow, and it is only visible from the top. This clearly concludes that the Egyptians had a very strong understanding of the solar cycle, advanced mathematics, and astronomy. But the question still lies, who was this meant for?